Okay, welcome to the video lesson for Wednesday, May 30th. It's on present value. So we're going to learn how to calculate present value, and we're going to rearrange the compound interest formula to come up with that formula. So the present value formula has to do with compound interest. So if we start with our compound interest formula, A equals P 1 plus R over C to the CT. When you're being asked to find present value, really that's asking you for the principal. It's asking you for P. So if we want to solve for P, we're going to divide by everything that's not P. So divide everything by 1 plus R over C to the CT. And when you do that, that cancels, and you're left with A 1 over R over C to the CT equals P. If you don't like fractions and you don't want to deal with fractions, we can rewrite that formula. Based on our knowledge of our exponential unit, if it has a negative exponent, it sends it to the other side of the fraction, or sends it down to the bottom or up to the top. So I could also write this as P equals, and instead of having this fraction here, instead of having all that in the bottom of the fraction, I can just have A bracket 1 plus R over C to the negative CT. Either one of those versions of the formula you can use. You can use option number 1 over here if you like fractions, or if you don't like fractions and you're comfortable with that negative exponent, you can use option number 2. If you borrowed money for 2.5 years at 6.25% compounded quarterly and owed the bank $5,000 at the end, how much did you initially borrow? So first thing, you're looking for the word compounded. That's how you know you're using a compound interest formula and not your simple interest triangle. And then the difference between yesterday and today is going to be yesterday asked you what's the future amount. Today it's asking you stuff like what is it worth today? What is it initially going to be? How much money did you originally invest? That kind of stuff. That's how you know it's present value. So how much did you initially borrow? That's asking you for the here and now. So that's how you know it's present value. Start out like we did before. A equals P equals R over C CT. The final amount, it says you owed the bank $5,000 at the end. So your future value was $5,000. It's asking you how much did you initially borrow. That's our question mark. Our interest rate, 0.0625. Your compound period, it says compounded quarterly, so over 4. And the time was 2.5 years. 4 times 2.5 is 10. Let's double check to see if our R over C value ends up being a nice decimal. Relatively nice. 0.015625. For this lesson, I'm going to use the formula number 2, the one that has the negative exponent. If you don't like that one, then you can continue the lesson doing option number 1, which has the fraction. So P equals 5,001 plus 0.015625 to the negative 10. And you can type that into your calculator all in one step. Let's have a look and see what we get. So I get 4,281, and if we round, 90 cents. Like yesterday, for an investment or for a loan, when we're looking for future value, it should always be more. That makes sense. You're either earning interest or you're being charged interest for the cost of borrowing. For today, this answer makes sense. Present value should always be less than what the original amount was. So we ended up having to pay back $5,000. The cost of borrowing means I initially borrowed $4,281.90. I was charged interest from the bank. It ended up costing me $5,000. So if you get something that's more, then you might have done something wrong. And therefore, you guys can fill in your own therefore statement. Example number 2, how much money would you have to invest at the age of 17 if you wanted to have $10,000 when you turn 30, if the interest is 4.25, compounded monthly, and how much interest was earned? A, P, R over C, CT. So he wants the future value, you want $10,000. So that's your future value. How much would you have to invest at 17? Assuming you're 17 or soon to be 17, that's like the now. So there's our question mark. Our interest rate, 0.0425. Our compounding period, so that's monthly. Let's double check to see if that's a nice decimal or not. Does not end up being a nice decimal, so I'm going to leave it as a fraction. And your time, how many years are there between 17 and 30? 13. Twelve times 13 gives you 156. Using our formula, P equals 10,000, 1 plus 0.0425 over 12 to the negative 156. You can enter that calculator all in one step. Again, if you have a type 1 calculator that displays all your steps on the screen, otherwise you got to do it step by step if you have a type 2. So let's see what we get. So I get 5,760 and rounding 71 cents. So if you wanted $10,000 at that interest rate and compounded monthly, you could invest 5,760 and change on your 17th birthday, and on your 30th birthday, you could collect $10,000. The second part of the question, how much interest was earned? So if we want to calculate how much interest was earned, take how much money you walked away with, your future value, subtract your principal, your initial investment, and that will give you how much money you actually earned. So 10,000 minus 5760 decimal 71, 4,239.29. And that's how much interest you earned. Put in your own therefore statements. Therefore, I invest this much when I'm 17. Therefore, the amount of interest I earned was this. Example 3, 6.5 years ago, $500 was invested in an account that paid interest that was compounded monthly. It is now worth $670. What was the interest rate? So in this case, we're looking for R. A equals P equals R over C equals, and CT equals. Our final amount, $670. The present value or principal value, what you paid originally 6.5 years ago, $500. The R value, we don't know. The C value, the compounding period is 12. And down here for CT, 12 times 6.5. should end up with 78. So fill in everything you know into your formula and solve for R. So 500 equals 670. One plus R over 12 to the negative 78. Divide both sides by 670. And over here on the left, when you do 500 divided by 670, you're going to get 0. We'll go 3 decimal places. 746 equals 1 plus R over 12 to the negative 78. Yesterday, or the last lesson we did, we had a 48 up there. We took the 48th root. Let's try and see what happens when we take the negative 78th root. So when we find the negative 78th root of 0.746, you should get 1.00376 equals 1 plus R over 12. Now we're going to stop for a second. If you did not get that, probably I know why. When you enter this into your calculator, the negative 78th root, you need to put this negative 78 in brackets, and then use the little X root button of 0.746. If you don't put that in brackets, you're going to get, some of you might have gotten negative 0.99. That's because your calculator doesn't know you want the negative 78th root, so it takes the 78th root of 0.746 and then multiplies it just by -1. So make sure you enter the negative 78th root in brackets like that, and then use your second function shift button to find the nth root of 0.746. From there, it's pretty straightforward. Subtract 1 from both sides. When you do that, you're going to get 0.00376 equals R over 12. Cross multiply both sides times 12. And when you do that, you should get 0.0452, let's say, if we round, equals R. And then they convert that to a percent, multiply by 100, and you end up with 4.52% per annum. Before moving on, one quick point to make. Some of you may be noticing, or maybe not, that you actually have enough information to use the formula we used yesterday, the normal future value compound interest formula. We basically did that question yesterday. So I did it using the present value just because that's the lesson we're in, but when you're given both A and P, you can use whichever formula you want. And if you wanted to use the formula from yesterday, all that would happen is that this 500 here would switch spots with the 670, and then you obviously wouldn't have a negative exponent here. And if you did it that way, you would get the exact same answer. That's it for our present value. Very, very similar to yesterday, just one little change to our formula. And then, like I said, Thursday I may or may not be back, depending how we do on Wednesday. If I'm not back on Thursday, Thursday will just be kind of an exam review period for you to work on your exam review. And then all these things will get pushed back a day. So we'll do annuities on Friday. And then Monday will be present value annuities. And then Tuesday will be review, and your test will still be on June 6th. So as it stands right now, I basically have 2 review days built in for you. Monday, loose ends. Tuesday, review. That loose ends day essentially is going to be just another kind of review, go over some questions. We can't really afford to push our test back anymore after Wednesday, so even if I'm not here on Thursday, the test is still going to be on Wednesday. There is your seat work for today. Have a good night, have a good class on Wednesday, and I will see you either Thursday or I'll see you Friday, or if you're not here on Friday, then have a good weekend, have a good Friday, and I will see you next Monday.